starting topic 3.3, which is sine and cosine function values. So the first thing we're going to talk about is coordinates of a point on a circle centered at the origin. So it says, given an angle theta in standard position on a circle with radius r centered at the origin, there is a point P where the terminal ray intersects the circle. So it says from topic 3.2, we know that cosine of theta is equal to x over r because cosine is my horizontal displacement over the radius. And sine of theta is equal to y over r because y is my vertical displacement over the radius. So what we have here is, here's my horizontal, here's my vertical displacement, and so cosine is horizontal over r. Okay, and then, so what happens is this. If I take these two equations and we multiply both sides of the equations by the denominator r, we get the result as x equals r cosine theta and y equals r sine of theta. So thus the coordinates of P, instead of being an ordered pair x and y, we can also say that it's r cosine of theta and r sine of theta. Okay, so that's just another way of seeing this. So let's take a look at example number 1. Example number 1, it says the figure above shows a circle of radius 4 along with the equilateral triangle PQO. So first of all, because the radius is 4, that means PO is 4. That means that QO is going to be 4. And that also means that PQ is going to be 4. And also, O to this point is also going to be 4. So I'm just highlighting them as well. And O to this point is going to be 4 as well. Now, because it's equilateral triangles, I can also connect here, and I can also connect here. So what you see is there are 3 equilateral triangles in order to create this one circle. So there's an angle here, an angle here, and an angle here. So over the span of 0 to pi, I have 3 triangles, which means that this is 1 pi over 3 over here, and this is 2 pi over 3 over here, and then we have 3 pi over 3. So therefore, which of the following coordinates gives the coordinates of point Q? Now we know that the radius is 4, so when we do 4 cosine theta and 4 sine theta, that's what we're looking for. So the question is, what's theta? So again, we just discussed it, so that means that theta is going to be 2 pi over 3. So r cosine of 2 pi over 3 and r sine of 2 pi over 3. Also, if you think about it just from an angle point of view, pi over 3 would only leave you in quadrant number 1. 5 pi over 6 is actually going to take you a little too far. 5 pi over 6 would be kind of over there at 150 degrees. Okay, and then negative 4. So we haven't talked about negative radius yet, or what we would do with that. But we could, we'll talk about that one afterwards. Okay, so that would be letter C. Turning the page, example number 2. So it says the figure above shows a circle of radius r along with the line y equals negative x. The circle and the line y equals negative x intersect at the points r, o, and p. So if the coordinates of point P are at 6 root 2, negative 6 root 2, what is the value of r, the radius? So if you notice, if I just make my little triangle here, my horizontal displacement is 6 root 2, my vertical displacement is negative 6 root 2, and my radius is unknown. I have a right triangle. So because I have a right triangle, I can use Pythagorean theorem here to find the radius. So I'm going to use 6 root 2 quantity squared plus negative 6 root 2 quantity squared equals r squared. Notice that I put negative 6 root 2. When we're talking about side length, it's actually a positive 6 root 2. It's just the vertical displacement is negative. But in any case, it doesn't actually matter because what happens is when I square it, it's still going to end up positive anyways. So 6 root 2 times 6 root 2 is 36 root 4. And 36 root 4 gives me 36 times 2, which is 72. So this is 72 plus 72 equals r squared. So r squared is equal to 144. So that means that my radius is going to be 12. Okay, so Pythagorean theorem comes into play there. Example number 3, it says consider the unit circle. So because this is a unit circle, and if you notice from O to P, the distance is 1. That means that the radius of this circle is going to be 1 unit. That's useful to know. And the reason why that's useful to know is because that means that sine of my angle, whatever my angle is going to be y over r. But in this case, because the radius is 1, that means that sine of my angle is just going to be the y coordinate. And if I do the same thing for cosine, cosine is my horizontal over the radius, but because my radius is 1, cosine of my angle is just going to be the x coordinate. Okay, so first one, if I do cosine of 0 is just saying at 0 degrees, what's the x coordinate? So in this case, the x coordinate is just 1. For letter B, what is sine of 0? So when you're doing sine of 0, it's asking you what's the y coordinate at 0. So the y coordinate of 0 is 0. So sine of 0 is 0. Okay, cosine of pi over 2, the x coordinate is 0. The y coordinate is 1. At pi, the x coordinate is -1. The y coordinate is 0. And at 3 pi over 2, the x coordinate is 0. And the y coordinate is -1. So at these 4 quadrantal angles, 0, 1, 0, -1, 0, 0, -1, cosine is the x coordinate and sine is the y coordinate. Okay, turning the page. So now we're starting to fill in the unit circle a little more. So it says a large portion of this course requires that we can find numerical values for functions involving sine and cosine at important angle values. The angles that we've been working with on the unit circle involve multiples of pi over 4, our 45-degree angles, and pi over 6, our 30-degree angles. Now we're going to put together several ideas to help us with this task. So consider the unit circle above, radius of 1, with an equilateral triangle. So because it's an equilateral triangle with a radius of 1, that means that OP is 1 unit, that pink line is 1 unit, and that line is also 1 single unit. Okay, and so what's going to happen is because of that, the perpendicular bisector occurs, and what's going to happen is you have this triangle right here where the radius is 1 unit long and it has a vertical height of 1/2. So because this is a right triangle, we're going to use Pythagorean theorem. A squared plus b squared equals c squared. So what you'll notice here, my a squared plus b squared, we replace the y with the 1/2, and we replace the radius with 1 because that's what we know. Once we are here, 1/2 times 1/2 is 1/4. If you subtract the 1/4 to the other side, you have x squared equals 3/4. To undo this, you take plus or minus square root. The square root of 3 we don't know. The square root of 4 is 2. So we have plus or minus the square root of 2. But since P is in quadrant number 1, we know that the x coordinate is the positive square root of 3 over 2. And the coordinates of P are now root 3 over 2, 1/2. Additionally, we know that the coordinates of P can be expressed as cosine of theta, sine of theta, which leads us to 2 important values. And that means that the x coordinate is the cosine of the angle and y is the sine of the angle. So cosine of pi over 6 is root 3 over 2, which we're going to make a flashcard for. Sine of pi over 6 is equal to 1/2. In addition to that, we could also use degrees. That means cosine of 30 degrees is also 3/2, root 3 over 2, and sine of 30 degrees is equal to 1/2. Okay? And it says, notice that we found 2 values of x when solving with the Pythagorean theorem, the positive and the negative. This is because there is another point in quadrant 2 of the unit circle where the y coordinate is 1/2. So using this symmetry, this point would be at 5 pi over 6 radians. So we're talking about on this side over here, and then creating that second triangle like that. And so that's where the x value is negative, but the y value is still a positive 1/2. So right over there. Okay. Number 2, the Pythagorean theorem plays an important and an interesting role with trigonometric functions. We will see additional ways that the Pythagorean theorem becomes useful later in unit number 3. Okay, so turning the page. Example number 4. The figure above shows a unit circle with equilateral triangles QRO and PSO inscribed. Use the symmetry of the unit circle to find the coordinates and angle measures for the points Q, R, and S. Okay, so as far as the coordinates are concerned, okay, if this is X and Y, Q is going to be negative X, positive Y. So Q, my coordinates are going to be negative root 3 over 2, positive 1/2. R is going to be negative X, negative Y. So negative X, negative Y, negative root 3 over 2, negative 1/2. And then S is going to be positive X, negative Y. So we're looking at root 3 over 2, comma, negative 1/2. As far as the angle measures are concerned, okay, so this first one is going to be pi over 6. Okay, so what that means is this spot right here is also pi over 6. This angle here is pi over 6. This angle here is pi over 6. However, when we are doing standard position, what that means is we want the angle from here to this point right there. So what that means is, if you notice, this is pi or 180 degrees. In order to get this angle from here to here, let me highlight that better. In order to get this angle, what I want to do is I actually want to take the 180 degrees, the pi, and I want to subtract my angle from it. So in order to get my angle there, if I do pi minus pi over 6, that's 6 pi over 6, that leaves me with 5 pi over 6. Okay, so anything in quadrant number 2 is going to be pi minus theta. In quadrant number 3, I actually want to go from standard, and I want all of these things here. So what that means now is this angle in quadrant number 3 is going to be pi plus theta. So pi plus pi over 6 leaves me with my 7 pi over 6. Okay, and then in quadrant number 4, the angle that I'm trying to represent, standard position all the way around, and then stopping at the terminal ray. So what's going to happen there is this is 2 pi over here. So in order to get this one, in quadrant number 4, it's 2 pi minus theta. So 2 pi minus theta, I have 2 pi minus 1 pi over 6. So 12 pi over 6 minus 1, that leaves me with 11 pi over 6. So these are the 4 that are together with my denominators of 6. Okay, so 1 pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So just as we did earlier in these notes, for an angle of pi over 6, we can use the unit circle along with Pythagorean theorem for my pi over 4s. So using the exact same thought there, okay, my radius of 1, and so what's going to happen is this. I'm going to draw 4 isosceles right triangles. So isosceles right triangles means that this side is congruent to this side. And so if you think about Pythagorean theorem, if these two sides are the same, instead of x squared plus y squared equals 1, because you have two congruent sides, you have x squared plus x squared equals 1. And so what happens here is you have 2x squared equals 1. You divide both sides by 2, so you have x squared equals 1/2. And then you take the plus or minus square root of 1/2. So the square root of 1 is 1, the square root of 2 is still there. Now, you learned in Algebra 2 how to rationalize the denominator. So when you rationalize the denominator, it becomes root 2 over 2. So 1 over root 2 is the same thing as root 2 over 2. So that means that the x and the y coordinates for pi over 4 are all going to be congruent, the same. So in quadrant number 2, again, the x becomes negative, the y stays positive. In quadrant number 3, x and y are negative. In quadrant number 4, the x is positive, oops, and the y is negative. Okay? And because these are my pi over 4s, they're all my multiples. So again, for quadrant 2, pi minus pi over 4 leaves me with 3 pi over 4. Pi plus pi over 4 leaves me with 5 pi over 4. And then 2 pi minus pi over 4, that leaves me with 7 pi over 4. Okay, so what you should notice here is this. All of my pi over 4s, whether it's sine or cosine, they're all root 2 over 2. The only difference is it positive or is it negative? And that depends on which quadrant it's in. So the pi over 4s are nice because you know the answer is root 2 over 2 or negative root 2 over 2. Okay, the very last one. The figure above shows a unit circle with the equilateral triangles PQO and SRO inscribed. Use the symmetry of the unit circle to find the coordinates and angle measures. Okay, so it took the equilateral triangles and they moved it up instead of so if you go back to the previous one, my equilateral triangles were across the x-axis, but this time we're taking the equilateral triangles and we're moving them across the y-axis. So because it's moving across the y-axis, that means the horizontal displacement is 1/2 to the left and also 1/2 to the right. Okay, so in that case, using that same thought, when I reflect it across, my x becomes negative, my y stays the same. When I go into quadrant number 3, my x and my y are negative. When I go into quadrant number 4, my x is positive, but my y is negative. Okay, these are my pi over 3s. Okay, so I have 1 pi over 3. The next one, I have pi minus pi over 3. So that leaves me with 2 pi over 3. I have pi plus pi over 3. So that leaves me with 4 pi over 3. And then the last one is 2 pi minus pi over 3. So that's 6 minus 1, which leaves me with 5 pi over 3. So all of my pi over 3s are together. The unit circle below displays all of the angles along with their coordinates that we will use repeatedly throughout Unit 3. So, as long as we know the coordinates of the important angles in quadrant number 1, we can use symmetry to find the coordinates in the other 3 quadrants. Okay? Now, again, when you are in quadrant number 1, your pi over 4, which is your 45-degree angle, you know that they're both root 2 over 2. You know that at 0 degrees, because the radius is 1, it's 1, 0. And you know at 90 degrees, because it goes up 1, it's at 0, 1. So, what I tell myself is this. I tell myself, all I have to remember is sine of 30 is 1/2. Because if I remember that sine of 30 degrees is 1/2, that gives me this point right here. And once I know that this point is right there, that means that the x-coordinate is the root 3 over 2. And what you should notice is, at 30 degrees, the y-coordinate is 1/2. At 60 degrees, it switches over. And then, at 30 degrees, the x-coordinate is root 3 over 2. And at 60 degrees, the y-coordinate is root 3 over 2. So as long as you know which one is which, now it's just a matter of symmetry, because the 1/2 root 3 over 2 connects there. It connects with the pi over 3, and it also connects with the 4 pi over 3. So you can see how everything is connected there. So again, like I said, all I commit myself to memorizing is sine of 30 equals 1/2, and everything else should take care of itself because of the symmetry and because I know what's supposed to follow. Okay, so what I'm going to do is I'm going to have you pause here. If you need to, you can fill in the other side of the unit circle based on symmetry. Okay, keep in mind, whenever you have the x and the y values and you're trying to do sine, cosine, and sine and cosine, the x coordinate is your cosine of theta, and then your y coordinate is your sine of theta. So if you want to find sine of 2 pi over 3, you find out where 2 pi over 3 is on the unit circle, and you're just looking for the y coordinate of that point. Okay, so I'm going to pause here. I'm going to let you try this and finish it up. Okay, as we go through example 7, I want to share one acronym with you that is taught usually in our pre-calculus. So it's called All Students Take Calculus. Okay, and so what All Students Take Calculus is if you go around the 4 quadrants, all students take calculus. It tells you which of your trig functions are positive in those quadrants. So in quadrant number 1, A means that they are all positive. So that means that sine, cosine, and then eventually you'll learn tangent. Sine, cosine, and tangent are all positive. So if you're in quadrant number 1, none of your ordered pairs and answers should ever be negative. Okay? In quadrant number 2, students, that means that sine is going to be positive. So that means that the negative values are going to be cosine and tangent in quadrant number 2. Okay? In quadrant number 3, only tangent will be positive. So my negative values are going to be sine and cosine. And in quadrant number 4, cosine is positive. So that means that my negatives are going to be sine and tangent. So if you know that you're trying to find something in that quadrant, you know what your answer should be as far as positive or negative goes. Okay, so 7a, I want to find sine of 2 pi over 3. So sine is going to be the y value. It's going to be in quadrant number 2. So if I go to my pi over 3, here's my y value. And in quadrant number 2, I know that sine is positive. So what that means is that my y value is still going to stay positive. My answer is just going to be root 3 over 2. And that's all I need there. For letter B, I'm doing cosine of 5 pi over 4. So cosine is the x value. 5 pi over 4 is in quadrant number 3. So that means that at 5 pi over 4, I know it's my root 2 over 2's, but it's going to be negative. So negative root 2 over 2. Okay. Letter C, cosine is the x-coordinate. 11 pi over 6 is in quadrant number 4. All students take calculus. That means I know that my answer is a positive because it's in quadrant number 4. So 11 pi over 6 means that I take a look at my pi over 6 over here. Okay, and my x-coordinate is root 3 over 2. So therefore my answer is a positive root 3 over 2. So that's how I'm using this without even filling in the unit circle. I'm just using quadrant number 1 and the idea of symmetry. Okay, letter D, sine of 7 pi over 4. So it's my y coordinate. It's in quadrant number 4. All students take calculus. I know my answer is negative. Because it's the pi over 4s, I know it's root 2 over 2. So my answer is negative root 2 over 2. Okay, 4 pi over 3, cosine. So cosine is the x coordinate. 4 pi over 3 is in quadrant number 3. So because it's in quadrant number 3, I look at pi over 3. The x-coordinate is 1/2. So cosine is negative. It's negative 1/2. Sine is my y-coordinate. 7 pi over 6 is quadrant number 3. Quadrant number 3, I know sine is negative. Because it's the pi over 6, it's the y-coordinate, so 1/2. And so because it's negative, my answer is negative 1/2. Cosine of pi, that's my x-coordinate at pi, so that would just be negative 1. Sine of 3 pi over 2, the y-coordinate, so that's my 6 o'clock time, so that's also going to be negative 1. Cosine x value, 2 pi over 3, quadrant number 2, so it's going to be a negative. I look at my pi over 3. My pi over 3 is 1/2, so it's negative 1/2. Cosine of pi over 3, we just did pi over 3, so I know it's going to be 1/2. And this is the x-coordinate. 5 pi over 3 is going to be in quadrant number 4. So because it's in quadrant number 4, it's going to be positive. Sine of 0, the y-coordinate at 0 is going to be 0. And then the last one, cosine of pi over 2. It is the x-coordinate at 12 o'clock. So the x-coordinate at 12 o'clock is 0. So hopefully you're starting to see the relationship between all of these things. and how if you know quadrant 1 and you know the reflections and things like that, it's actually not too bad. So we will be making flashcards on these things, so that way it helps us recall these facts a lot quicker. Okay, so good job. I'll see you guys in